Okay, and welcome back for students of Math for Business and Finance and Math Applications. Again, we're picking up where we left off for the drill, Chapter 3 drill problems, the odd number problems that were assigned as part of the lesson. Last video was we finished with 3-25, so let's pick up with 3-27. Okay, it says here, convert the following mixed numbers, do not reduce to the lowest term. Okay, so again, remember that I had said in the previous video that the decimal place is extremely important, okay? Because why? The numbers to the left are whole numbers and the numbers to the right are fractions of a whole. So basically, when you're thinking about this number, what you have is, and I'm just going to, well, actually, let me create another example to make it a little easier. Let's say I have 2 and 2.5, okay, or 2.5, right? Well, what this means is that I have two whole numbers, okay, two whole things, and then I have a half of something else, okay? So think of it, I have 2 apples and somebody cut an apple in half, right? So that's the representation. So when I'm looking at a mixed number like this, here I'm going to keep my 28 whole numbers, and what I need to do is I need to convert this fraction portion, the 0.48, into this decimal portion into a fraction. And again, we already know how to do that from the previous homework examples. So if I have 0.48, all I need to do is go say I have 1, 2, so it's 48, and 48 over 2, 1, and then 2 zeros over 100. Why is the pen not working? So my fraction ends up being 28 and 48 100ths. Okay, it's just basically that simple. Okay, when we're looking at a number with decimals, we think in terms of whole numbers, and we think in terms of fractions, and we can convert that decimal as a fraction of a whole number into an actual fraction and just tack it on there. So we convert it to the mixed number 28 and 48 100ths. Okay. All right, 3-29. Write the decimal equivalent of the following. 5 thousandths. Okay. Because it's thousandths, the THS, I know that the 5 is going to go in the thousandths place. So this is a thousandths place, this is a hundredths place, this is a tenth place. I put my 0, and like I said, I like to put the leading 0, so my answer ends up being 0.005 because the 5 is in the thousandths place. 331. Write the decimal equivalent of the following. Okay, 85 ten thousandths THS. Okay, that means it's a fraction of a whole. So I have 85, and since the 5 is in the 10 thousandths, the 8 is in the thousandths, my hundredths, my tenths, TENTHS, put my decimal and the leading 0. So my answer is 0.0085. Simple. All right. Drill problem 3-33. Rearrange the following and add. Okay, because it's asking us to rearrange, what that means is we want to write the numbers so that all of the decimal places are lined up correctly. And this is what I have alluded to in previous videos about making sure your positioning is correct. Okay, so I have 0.115. So we have to keep all of our decimals underneath each other and position our numbers accordingly. So when I write the 10, I keep the decimal aligned, 8318. Then I have my 4, put the 0.7, and then I write the 802, the decimal place, 4811. Okay, so the important thing here is again, by keeping everything aligned, keeping the decimals aligned, and keeping each position aligned, it makes things a lot easier to be able to add. If I just start willy-nilly putting, if I went, as an example, 1.5, and then I went 10.8318, and then I went 4.7, and then I went 802.4811, this becomes very difficult for me to be able to add up. Nothing is aligned in their proper positions. So you don't just scribble numbers onto a paper, okay? You make sure everything stays aligned. And you'll see me oftentimes when I do get sloppy, I'll erase it and realign everything and do it the right way. So do the math. That's 9, that's 7, that's 9, 12, 10, 21, 2, that's 8, 1, 8. So my answer is 818.1279. Now, let me look in the book. Yep, that's the answer that they have in the book. Okay, rearrange the following and subtract. So 9.2, and again, keep things aligned by the decimal place. There's my decimal, so I have 4. 5 from 8 is 3. 3.4. Boom, simple. Rearrange the following and subtract. 3.4, 1.08, keeping the decimals aligned. Now, 8 from, remember this is a trailing 0, we can just add those in for as many numbers as we need to go to the right, because 3.4 is the same as 3.40 or 3.400. This is all the same exact number, no matter how many zeros I add after that final digit there. So when I don't have a digit here like this, I understand that that's a 0, right? So 8 from 0 is 2. Well, actually 8 from 10. Why? Because I'm going to borrow 3 here. I'm going to make this a 3. That makes this a 10. So doing the basic math, 8 from 10 is 2. 0 from 3 is 3. 1 from 3 is 2. 2.32. 339. Estimate by rounding all the way and multiplying the following. Okay, so the first thing I'm going to do is estimate by rounding all the way, okay, which means I'm going to round all the way to the most applicable number, all right, which in this case for the 0.413, I have to look at the 4 in the 10th position, go to the right, see it's a 1, it's less than 5, so I'm going to round down, so my 0.413 becomes 0.4, and my 3.07, rounding all the way, I'm looking at the 3, go to the right, that's a 0, so I'm going to round down, so that ends up being a 3, and I'm going to multiply the 0.4 times 3, which that gives me 12, and I have only one decimal place here, so I move the decimal here, my answer ends up being 1.2. Okay. Next, estimate by rounding all the way and multiply the following. So again, 4.9. Start out with the 4, look to the right, it's a 9, greater than 5, so I'm going to round up. So 4.9 becomes 5.0, or 5, and 0.825. I start out with the 8, look to the right, it's a 2, it's less than 5, so I'm going to round down, so that ends up becoming 0.8, excuse me, and I multiply one by the other. So I'm going to take 0.8 times 5, which is 40, and since I have one decimal place, I'm moving it here, right, from here to here. And so my answer is 4.0, or just 4. Okay. Now remember, you could have done this, I multiplied 0.8 by 5, okay. I could have multiplied 5 by 0.8 like this and come out with 40. and I have one decimal place here, so I put it there from here to here, and I end up with the same 4 or 4.0. Right? The reason why I did it 0.8 times 5 was just so that you realize that when you multiply, it doesn't matter which order you multiply the numbers in. All right, whatever looks or is more convenient for you, and you end up with the same answer. Okay, that's just a multiplicative property. You can rearrange the numbers whichever way you want, multiply, and still come up with the same thing. Okay, so I'm going to stop here and pick up with 3-43 in the next video.